Hey, Algebra 2. We are still in Chapter 5, Section 2. And as usual, please do not ignore the warm-ups. They are an excellent way to remind you of important concepts before we expand on those in today's lessons. If you remember, sorry, class is over. If you remember, here we see that this is vertex form of a parabola. I know we're going way far back, but it's x minus h squared plus k, where this is left and right, and this is up and down. If we're trying to find the domain and range, a parabola, when it's positive on the outside, opens up. This means I am down to -2. My domain is my input, is my x value. My range is the output, or the y values. If I look at this graph, I see that x values, this graph goes forever and ever in that direction. Therefore, it covers every single x value in the number line. So my domain would be all real numbers. The range is not quite as simple. It only covers, if I just look at where the parabola covers, this part of the y-axis. Therefore, my range would be any number greater than or equal to 2. -2, sorry. So we have domain and range. Here is also the vertex form of a parabola. This means I'm going up 5. I guess I should have said this means I'm going down 2, which is why, oops, why I went down to 2 on the y-axis. Sorry about that. So up 5, we don't care about left and right. This right here means it opens down. So my parabola is not a happy parabola, it's a sad parabola. It opens down, but the top of it is a 5. Therefore, my domain, again, is going to be all real numbers. And my range is just going to be where it covers the y-axis, that part right there, which is y is less than or equal to 5. Still warming up. Explain how the graph of y equals x plus 2 quantity squared minus 6 can be obtained from the graph of x squared. Okay, this right here means I'm going to the left 2 units. H equals -2 because it's x minus h squared plus k. And this one right here means k is -6, so I'm going down 6 units. All right, let's learn some new stuff. We are still talking about rational functions. It's the main topic of this chapter. What is a rational function? Well, a rational function is an equation or a function in this form. Remember, this is just function notation. It's how we name it, not a big deal. But it is equal to f of x, is what this says, is equal to p of x over q of x, where p of x and q of x are polynomials. Polynomial is a many monomials put together in addition and subtraction. And q of x cannot equal 0 because we cannot divide by 0. Okay, the universe explodes, just doesn't work. This inverse variation function f of x equals a over x is a rational function. That's what we did in section 1. The graph of this function when a equals 1 is shown below. So we're graphing f of x equals 1 over x right here. This is called the parent function for a simple rational function. Okay, that's the parent, where a equals 1. So that is called a hyperbola, which consists of 2 symmetrical parts called branches. The domain and range are all non-zero real numbers. Our domain and range, this is my input, my x value, my output, my y values, they are all non-zero real numbers. Any function of the form g of x equals a over x, where a doesn't equal 0, has the same asymptotes, domain, and range as the parent function. Okay, so it's important with the parent function, a vertical asymptote, vertical is up and down, vertical is up and down. My vertical asymptote is always x equals 0. My horizontal asymptote, which is left and right, just like the horizon that we look as the sun comes up every morning, just as the center part of the H in the first letter of the word horizon, and that is y equals 0. All right? Stick with me. Don't give up yet, or don't stop listening. Okay, here is my coordinate plane, right? These are all, this is my x-axis, this is my y-axis. My x-axis is horizontal, but to draw a line through the x-axis, I have to draw a vertical line. Okay, so that is my x equals asymptote somewhere. Okay, it's going to move from the axes as we get harder. Okay, again, stick with me. On my x-axis, yes, my x-axis, on my y-axis, that's my vertical axis, but to draw a line on the vertical axis, I have to go through it, which I draw a horizontal line. So y equals my asymptote. That's my horizontal asymptote, is always y equals. My vertical asymptote is always x equals. Okay, practice that a few times, write this down, and memorize it. All right, let's try one. Graph the function y equals 6 over x. Compare with the graph of y equals 1 over x. First, we're going to draw the asymptotes. So I'm going to get, let's see, let's do this. Hold on, I'm sorry. I know I'm over-exaggerating. I hope you don't get too annoyed. All right, my my asymptotes are x equals 0 and y equals 0. So I'm going to use highlighter. That is y equals 0, x equals 0, my horizontal and my vertical asymptote. So I've drawn those asymptotes. I can plot points to the left and to the right of the vertical asymptotes. I don't want to still be in red, sorry. There we go. I'm just going to plot a few points. Let's see, -3, -2, 2, and 3. If I plug -3 in, I get -2. I plug -2 in, I get -3, 3, and 2. So -1, 2, 3, -1, 2, -2, 1, 2, -3, 1, 2, 3. That's terrible, I just saw my points. Sorry. Okay, let's try this again. 1, 2, 3, 1, 2. 1, 2, 1, 2, 3. There we go. And that's actually going to reflect over here. So if I go over 1, 2, 1, 2, 3, 1, 2, 3, 1, 2. Cool. These are called the branches of the hyperbola. They pass through the plotted points as they approach the asymptotes. I cannot cross an asymptote, so I'm never going to cross this red line or that red line. That's what asymptotes do. If I were to graph the parent function right here, okay, my parent function is just a little bit closer to the asymptotes. Pretty cool. Both graphs are always going to lie in the first and the third quadrant. That's the third quadrant. And they're the same asymptotes. The parent function and x over 6 have the same asymptotes, the same domain, and the same range. And look, much prettier drawing. I kept that in there so we could see it because my drawings aren't so great. Cool. All right, moving on. We are going to start translations of these simple rational functions. Translations use the same basic form that we've been using for all the translations: logarithmic, exponential, parabolas, everything. We've got x minus h and plus k, where h is my left-right movement and k is my up-down movement. Okay, that has not changed at all, amazingly enough. So our asymptotes are going to be x equals h and y equals k. So we go to our function and we just grab x equals h, and that's going to be my vertical asymptote, and y equals k, which is going to be my horizontal asymptotes. And then we want to go ahead and plot some points to the left and the right of the vertical asymptote and draw the two branches. Okay? All right, let's try one of this form. So right up here, we have the form that we're looking at. Let's figure out our asymptotes. First, let's take the denominator here, x plus 2, but I need it to be in the form x minus h. So x minus a negative 2, therefore h equals negative 2. That is my vertical asymptote. I think that's LE. Yeesh, I think that's right. No, my spelling, I'm sorry. If we look at this one right here, I have k equals negative 1. That is the horizontal asymptote. Let's go ahead and draw our graph here and there, and the asymptotes. I've got h equals negative 2, 1, 2. So I have a vertical asymptote here and a horizontal asymptote at negative 1. Now, what we haven't talked about yet, but is still extremely important, is that leading term is a negative 4. That means we're no longer in quadrants 1 and 3. That negative 1 reflects things. So you can plot some points and know that the branches of the hyperbole are in quadrants 2 and 4. And that's because the negative in front of the 4 of the problem. Okay, that negative 4 right there reflects things. All right, notice we didn't actually plot any points, and that's okay. All right, I need you to know the shapes of the hyperboles, what quadrants they're in, how to find the asymptotes, etc. We can also talk domain and range. Domain are the x values, right? And if you look right here, the denominator of this problem is x plus 2. Well, that cannot equal 0, or the world explodes. So if we solve this for x, we can say x cannot equal negative 2. So the domain of this problem is all real numbers except negative 2. The range is the same thing. It's all real numbers except where the asymptote is. So we would say all real numbers except negative 1, because you'll never get a value at negative 1, which is why we wrote an asymptote there. So there are the domain and ranges. Oops, I forgot that part. And if you look here, you see the graph prettily, very nicely drawn by the textbook people. All right, let's try another one. Graph the function. You see here that you've got a negative 4 leading again. So your asymptotes are x equals 0 and y equals 0. But that negative means that we're going to draw our graph in quadrants 2 and 4, which is what we did. So I have an asymptote here and there, and then I can draw my branches. I just realized I forgot domain and range. Sorry, I don't know what I'm doing there. The domain is going to be all real numbers except 0, and the range will be also all real numbers except 0. Those are easy when they don't move anywhere, okay? Okay, here we're going to shift that down. So my asymptotes are at x equals 0 and y equals k, which is -5. So I'm going down here to 5 and drawing an asymptote. And there's my other asymptote. We have no negatives, so my branches will be drawn in quadrants 1 and 3. Excuse me. I don't think I said domain and range of the previous problem. I'll have to go back and do that. Sorry. The domain is all real numbers except 0. And the range is going to be all real numbers except -5. All right, a little more complicated. The horizontal asymptote is going to, well, let's do the vertical one first. So we have the vertical asymptote is going to be at x equals 3 because it's x minus h, which is x minus 3, therefore h equals 3. Our horizontal asymptote is going to be at y equals 2. These are my two asymptotes. Let's go ahead and draw those in. I've got up 2, draw a line, over 3, draw a line. Nothing here is negative, so I know I'm in quadrant 1 and 3. Life is grand. And then we can say our domain is going to be all real numbers except 3, and the range is going to be all real numbers except 2. Gets easier as you go, right? Cool. All right, just a tad bit harder. Now we're going to this form right here. So there's another thing you have to memorize. Okay, all rational functions of the form y equals ax plus b over cx plus d also have graphs that are hyperbolas. The vertical asymptote, make sure you write this down and highlight it. Vertical asymptote is the line x equals -d over c. Whew. Because the function is undefined when the denominator is 0. So if we say cx plus d cannot equal 0, subtract d from both sides, divide both sides by c, that's where that comes from. Okay, so that is my vertical asymptote. My horizontal asymptote is going to be y equals a over c. Okay, what you see is just the beginning, a over c. Okay, again, whew, I know, it's tough. So make sure you highlight that so we can use it easily for the next problem. Right, graph this and state the domain and range. Let's figure out the asymptotes. I want to solve this for x to find the vertical asymptote, x equals 3. Okay, there's nothing in front of here, so we don't have to worry about it. And then the horizontal asymptote, let me erase what I put right here. The horizontal asymptote is a over c. If we look right there, it shows us I've got 2 over 1, or 2. If we go ahead and graph this, horizontal asymptote is at 2. Let's do that in red. And the vertical asymptote is 3. I don't have any negatives out front. I'm just making this a little longer. So my graphs will be in quadrants 1 and 3. The domain is going to be all real numbers except the asymptote of 3, and the range is going to be all real numbers except the asymptote of 2. And there's the prettier graph with numbers actually plotted. All right, this example is a tad bit more difficult only because it doesn't have a leading negative, but it does graph in quadrants 2 and 4. I just utilized my graphing calculator to get the shape of it, which was pretty simple, but we can still go ahead and find the vertical and horizontal asymptotes. So for the vertical asymptote, I want to look at the denominator and say that x, there's a vertical asymptote at x equals -3. And the horizontal asymptote is a over c, which is 1. That's why we have a straight line here and a straight line there. All right, and then I went to my calculator to see the shape of it, which gave me my curve here and a curve there. You can also go ahead and plot a few points of, a few points left of the vertical asymptote, which would be, goodness, we can do -4, -5, and then to the right of the asymptote, let's see, -1 and 0. If I plug those in, I get, let me change colors, it's getting a little crowded in here. -4 minus 1 is -5 over -4 plus 3 is -1. So that's +5. So I'd go over -4, 1, 2, 3, 4, and up 5. Let's see, 1, 2, 3, 4, 5. 1, 2, this is 2, 4. There we go. Then same for -5. -5 minus 1 is -6. -5 plus 3 is -2. -5, yep. That'd be a +3. Sorry, I'm doing a poor job graphing here. 1, 2, 3, 4, 5, and up 3. So we see that it's in the second quadrant, and we know the other one's going to be in the fourth quadrant, just a reflection. All right, graph the function. First of all, we're going to look at the denominator. For the vertical asymptote, 4x minus 2, 4x equals 2, x equals 1/2, and the horizontal asymptote is a over c, 2 over 4, which is 1/2. That's a really hard one to see, but I've got 1/2 and 1/2. And I'm back in quadrants 1 and 4, which I peeked at my calculator and saw that, or you can plot a few points, whichever works for you. I forgot domain and range again. My domain is going to be all real numbers, except 1/2, and the range, is going to be all real numbers, except 1/2. Okay, last one. I have vertical asymptote, -x minus 1, -x equals 1, x equals -1. And horizontal asymptote is -3 over -1, which is just plain old 3. So I'm going for horizontal asymptote at 3, vertical asymptote at -1, and my calculator showed me I'm in quadrants 2 and 4 again, or you can plot a few points. My domain here is going to be all real numbers except -1. Range is going to be all real numbers except 3. Daily homework quiz. I didn't state the domain and the range of the last ones. Ugh. All right, so yeah, check this out. One more slide. And there you go. We actually didn't do this one, so don't worry about it.